Okay, so 5-7 inverse trig. I'm going to go through these integration rules, and then they will help you sort of to complete everything you need so that we can begin chapter 8. Section 8.1 is when you're responsible for looking at an antiderivative and being able to apply any type of rule to find the answer. Okay, so derivative rules, you would have learned these briefly last year, maybe done a couple examples of them. I understand that. So take a minute, copy these three down. And the derivatives of the c functions, so arc cosine of u, it's just the exact opposite of the derivative of arc sine. So it would be negative u prime over square root of 1 minus u squared. The derivative of the arc tan function, arc cotan of u is the exact opposite of the arctan, so negative u prime over 1 plus u squared. And then the derivative of arc cosecant of u, negative u prime over everything that remains. Okay, so to develop our integral rules, they'll be based on our derivative rules, because we know when we take the antiderivative of a derivative, they're inverses of each other. So we'll focus on arc sine, arc tan, and arc secant, because the fact that the derivatives of the arc cosine, cotan, and cosecant are just the opposite. They'll all fit into a form of arc sine, arc tan, or arc secant. Okay, so the antiderivative of du divided by square root of a squared minus u squared. So this resembles our derivative rule for arc sine. So this antiderivative is arc sine of u divided by a plus c, where a is any real number, and a would obviously be the square root of a squared. U is our expression in terms of x, and that's equal to the square root of u squared. Antiderivative of du divided by a squared plus u squared. This looks like the derivative rule for arc tan. Okay, it's the only one that doesn't have the square root. And this antiderivative is 1 divided by a arc tan of u over a plus c. And lastly, the antiderivative of the last. This resembles arc secant, and that's 1 over a arc secant of the absolute value of u divided by a plus c. So now using these rules require the need for u substitutions, finding the derivative of u, making those proper substitutions, and then applying the rule. So now these are in addition to every other rule that you've learned. Power rule, your trig rules, right? Natural log. All of those rules, we now add three new ones to them. All right, so example 1, find the antiderivative of dx over the square root of 1 minus 4x squared. So it looks like it's set up like arc sine. So a would be equal to the square root of 1. U is going to be equal to 2x. Du is equal to 2 dx. So to make a proper u substitution, I need my 1/2 out front. Okay, so I have 1/2 antiderivative of du divided by square root of a squared minus u squared. And then applying the antiderivative rule, 1/2 arc sine of u over a plus c. Now, of course, you don't need the divide by 1, but just to apply the rule, I'll leave that in there just so you can see the form of the rule. Antiderivative of 12 divided by 1 plus 9x squared dx. I'm going to start by bringing the 12 out front. And now this would be arc tan. We should be thinking arc tan because that's the only one that doesn't involve the square root. So a is going to be equal to 1 in this case. U will equal 3x. du equals 3 dx. So multiply by my 3, so I divide by 3 out front. So 4 du divided by a squared plus u squared. So to apply my rule, it would be 4 times 1 over a arctan of u over a. And then just cleaning it up a little bit. There we go. Alright, so thinking for this, again, could think arctan, because in the denominator we don't have any square roots. So a would be equal to 4, u would be equal to t. Oh, whoops, I wrote this down wrong. Sorry. That should be t to the 4th plus 16. So this would be square root of t to the 4th, which would be t squared. So then du equals 2t dt. So that's going to take care of the t that's in the numerator here. Okay, we know that the antiderivative rule is just du over a squared plus u squared. But the fact that we had another variable in there is okay. Our u substitution. So 2t, I bring my 1/2 out front. So 1/2 antiderivative of du divided by u squared plus a squared. So that'll be 1/2 times 1 over a arctan of u over a plus c. Multiplying my coefficients. My final answer. Now let's go back to this. So the antiderivative rule is a squared plus u squared, where our real number is first and then we add the expression in terms of x. We add the u there. So the original being u squared plus a squared, it doesn't change the derivative rule or the integral rule. It will matter when we do arc sine. The order will matter, but not for the arctan. All right, let's see here. So let's do a definite integral. E to the negative x divided by 1 minus e to the negative 2x from the natural log of 2 to the natural log of 4. Okay, so looking at the form, we should be thinking arc sine, square root of a squared minus u squared. Okay, so a is going to equal 1. U now, we have to think of what's being squared. So what's being squared? E to the negative x. So u will be e to the negative x. The derivative of that itself times the derivative of the exponent. So again, we have a function in terms of x here, but our u substitution will take care of that. Put a -1 out front. I don't have the dx in there. So I have negative ln of 2 to ln of 4 du divided by square root of a squared minus u squared. So our antiderivative rule, the opposite of the arc sine of u over a from the natural log of 2 to the natural log of 4. All right, let me complete this over here. So we have, I'm going to make it a positive exponent. from ln of 2 to ln of 4. Okay, so I have negative arc sine of 1 over e to the ln of 4 minus negative arc sine of 1 over e to the ln of 2. So negative arc sine, e and ln will cancel each other out, of 1/4 plus arc sine of a half. Okay, we talked about these with our review problems a little bit. So arc sine of a half. So when we're talking about our inverse sine function, this is our interval, negative pi over 2 to pi over 2. So on this interval, where does the sine function equal a half? At pi over 6. So we couldn't answer that question, where does the sine equal a fourth? But 1/2 is in the domain of the arc sine function. So this would be your final answer. All right, let's do one more example. What number is this? 5. So 0 to 1 over square root of 2, antiderivative of arc cosine of x over okay, so it looks like it could resemble the antiderivative being arc sine of x. Okay, but if we think about that, a would be 1, u would be x. So we still have this arc cosine, which won't be canceled from a u substitution. So let's think of something. Let's try a u substitution. If we picked u to be arc cosine of x, the derivative of that is negative 1 divided by square root of 1 minus x squared dx. So now that's what this problem will become. It's just a u substitution. Put the negative out front for the proper substitution. So we get negative 0 to 1 over square root of 2. And then this whole piece just becomes u du. So then this integral rule, negative 1/2 arc cosine of x from 0, and I'm going to rationalize this because we're more familiar with seeing it like that. And then oops, sorry about that. Then I'm squaring it. Okay, so now when I plug in my boundaries, negative 1/2 arc cosine of square root of 2 over 2 squared minus arc cosine of 0 squared. Arc cosine domain is from 0 to pi. So the arc cosine has a value of square root of 2 over 2 at pi over 4. The arc cosine is equal to 0 up at pi over 2. And then I would have to multiply that by negative 1/2. Okay, so for homework, simplify this answer.